last type of name and formula that we need to learn to write. Over the last couple days, we've learned to write the names and formulas for salts. The first time, we talked about writing actually just the formulas for what we called the simple salts. Then last time in class, you learned to write the names and formulas for what we call the complex salts, the salts that contain polyatomic ions. So you now have the ability to write the name or the formula given the other for simple and complex salts. What we're going to do today is we're going to do a similar process only with molecules. Remember, salts are the product of a positive metal and a negative nonmetal bonding together ionically. Molecules, which contain covalent bonds, are the product of groups of nonmetals. Remember those small, strong atoms that neither one wins and they share covalent bonding. Molecules are groups of nonmetals gathered together. And the way that we write their names and formulas is completely different from the way that we handle salts. As a result, you need to learn these rules as well. Thankfully, though, this is so much easier. You're going to see these are much, much easier to do. So, how do we write the molecular names and formula, or how do we write the names and the formulas for molecules? Well, this is where we are right now. You need to gather together your stuff to be ready. You need materials to take notes. You need a periodic table. And interestingly, you will need your yellow ion chart. Not because we need it to deal with molecules, but because in your homework today, you're actually going to be working with some salts as well. So you may as well have it available. So take a couple seconds, grab some note-taking materials, your periodic tables, and then your yellow ion chart, and we'll get started in just a moment. All right, so why don't we go ahead and get started? So again, this is where we are right now. You should be proficient at writing the names and formulas for these ionically bonded salts, simple and complex. Now we're ready to move past this. We understand that salts are a combination of a metal and a nonmetal or a polyatomic, as we said before. What we're going to do now is we are going to do similar work, this naming and formula writing process, but now we're going to do this with compounds, with molecules. And remember the difference. Again, as we said, salts are a metal and a nonmetal, or a metal and a polyatomic bonded together ionically. A molecule is different. Molecules are covalently bonded, and they involve the bonding of either two nonmetals, or remember the one exception of this, and that would be hydrogen. Hydrogen is that crazy strong metal that the nonmetals can't steal from, and so hydrogen also creates covalent bonds and therefore molecules. All right, so now we're ready to talk about the rules. How do you write the names and formulas for molecules? And guys, as I told you, this is so much easier than salts. Ready? It's this easy. It's not about parentheses. It's not about Roman numerals. It's not about working things backwards. It's not about least common multiples. It's none of that stuff. The entire process of writing the names and formulas for molecules is all about prefixes. And you need to know these prefixes. Write them down. The prefixes are these, but you're going to find that most of these are familiar. You know that mono means one. Monorail, one rail. You know that di is two. Then Then, guys, moving on from there, a tricycle, tri, is 3 wheels. You already know tetra because we've talked about tetrahedral. Perhaps you know that the Pentagon has 5 sides. It's a 5-sided building, or maybe you just know a pentagon has 5 sides. But our government building, the Pentagon, has 5 sides. You may or may not know hexa is 6. Maybe that's new to you. Perhaps you don't know that hepta is 7, but now you do. I'll bet you know that octa means 8 because we've talked about the octet rule. So octa is 8. Now nona is 9, which you may not know other than nana, kind of sounds like 9. And you all know that there's 10 years in a decade, so you know deca is 10. So these are the prefixes that you need to know in order to be able to write formulas and names. And guys, that's it. That's all you need to know other than one little rule. And it goes like this. When you only have one of the first atom, I would encourage you to underline first atom because that's important. If there's only one of the first atom, you do not use mono. And the second atom, just like with salts, ends in IDE. Guys, that's all there is to it. Mono is 1, di is 2, tri is 3, tetra is 4, pent is 5, hex is 6, hept is 7, oct is 8, non is 9, dec is 10. If you've only got one of the positive or the first atom, if there's only one of the first atom, it's not positive, these aren't ions. If you've only got one of the first atom, you don't use mono. And the second atom ends in IDE. That's all there is to this. So based on that, let's look at some examples. Write this down with me. So what would we call SF6? This is the idea. S is sulfur. F is fluorine, but we're going to change that to fluoride. Just like with the salts, we change the ending to IDE. Now all we have to do is indicate how many of each there is. Well, how many sulfurs are there? There's only one, but remember the rule. If there's only one of the first atom, we don't add mono. So this is not monosulfur, this is just sulfur. Then the second part of this is fluoride, but there's 6. So maybe looking back in your notes if you need, 6 is hexa. Oh, that's flour. UO. And this is what is called sulfur hexafluoride. That's it. No parentheses, no balancing charges, no Roman numerals, none of that. It's just sulfur hexafluoride. That's all there is to it. Let's take a look at another example. Next we have N2O. N is nitrogen, O is oxygen, which we'll call oxide. Now notice that we have 2 of the nitrogens. 2 is di, so this then would be dinitrogen. And now notice we have oxygen next, but only 1. We do, though, add the mono. There is only 1, but it's the second element, so we do add mono. Now, guys, we've got sort of a weird little ditty here because we've got mono and we've got oxide, so we've got 2 vowels pushed up against each other. So you could call this monooxide. But many people contract this, getting rid of one of the O's and calling it monoxide. Either one is acceptable. Dinitrogen monooxide or monoxide, either one is fine. Do notice, though, that it's 2 words. Dinitrogen monoxide. Let's do another one. Looking over here on the right, another form of nitrogen and oxygen bonded together. Notice now, though, we've only got 1 nitrogen, and nitrogen is first. Therefore, we do not call this mononitrogen, we just call it nitrogen. Then we have 2 of the oxygens, 2 is di, and we call this dioxide. Notice that we do keep these vowels, both of them, because they're not the same vowel. It is dioxide. Now guys, if this is starting to sound a little bit familiar to you, maybe it's because we've been writing the Lewis dot structure for this molecule for months. This is carbon dioxide. Notice it's not monocarbon dioxide because there's one carbon, but it's first. You may also know that there's another molecule that involves carbon and oxygen. This is carbon monoxide, not monocarbon monoxide, because it's only, you don't use the mono on the carbon. And then you probably know by ear that we don't call it monooxide, we call it monoxide, again for the reasons that we talked about earlier. So some of these things should be familiar to you. So now what if we want to go in the other direction? It's almost easier. We've got dichlorine octoxide. So we've got di, which is 2, and chlorine, which is Cl. So that means we've got 2 Cls. Then we've got octoxide, that would be oxygen, and there's 8 of them. That is all there is to this. One more example. Let's take a look at dinitrogen tetroxide. So again, di means 2. So we've got dinitrogen, and then we've got oxide, but now we've got tetra, which is 4. Dinitrogen tetroxide. And that's all there is to these. So let's look at one more example and figure out if we're really comfortable with what we're talking about. So let's try this. Say that we've got this chemical formula and we want to name this. So what is this? Well, given what we just learned, we would look at this and we would say that would be calcium, but not the mono because it's first. So calcium, and then sulfur, and we've got 1 sulfur, and then we would say there's 4 oxygens. So perhaps we could name this calcium monosulfur tetraoxide or tetroxide. And we get into the middle of that and we think that we figured out the name. And then maybe some of you are noticing this is wrong. The reason that calling this the reason that calling this calcium monosulfur tetraoxide is incorrect is because this isn't a molecule. This is a salt. And we don't use the prefixes with the salts. We use prefixes with molecules. We don't use the prefixes with the salts. And I suspect some of you saw this coming. Because guys, this is where this all comes together. In the previous 2 days, you learned to write the names and formulas for salts. Just now, you learned how to write the names and formulas for molecules. It's all about the prefixes, and it's pretty straightforward. The challenge then becomes this. How do you know whether you are naming a salt or naming a molecule? Because guys, you've got to be able to do this live, in lab, in the real world, if you will. When we go into lab in the coming months, you're not going to be told, this is a molecule, name it with prefixes. You're not going to be told, this is a salt, name it with Roman numerals. Those things are not going to be given to you. Those are things you're going to have to figure out and then use the right naming and formula writing rules based upon whether or not it's a molecule or a salt. So the question becomes, how are you going to know? Well, do this with me. Turn your attention to the table that you should have been handed at the beginning of the class period. This is the way to organize your thinking. So, question 1, how do you know if something is a salt or if something is a molecule? And the answer is this. Look at the periodic table either in front of you or on the wall and remind yourself, what atom pairings make salts? And the answer is a metal bonded to a nonmetal or a metal bonded to a polyatomic. Now ask yourself this, what atom pairings make molecules? And the answer is nonmetals. So do you see it? This is the trick. If the compound contains a metal, it will be a salt. If it does not contain a metal, it will be a molecule. So the first thing you're going to do is you are going to look at the first atom in the compound. Now, this will be a salt if the first atom is a metal. This will be a molecule if the first atom is a nonmetal. And once you know if it's a salt or a molecule, you then know how to write the name. So if it is a salt, writing the name could require Roman numerals. So remember what you learned last time in class. Look up the metal. So as you're doing this, what you're going to do is you're going to check the metal on the periodic table and figure out if it has more than one charge. If it does, then you're going to work it backwards and use a Roman numeral. If it does not have more than one charge, then you're simply going to name the salt. Remember that the second element, the second thing will end in "ide" if it is an element, and then it will end in "ate" or "ite" if it's polyatomic, again with the exceptions of cyanide, hydroxide, and peroxide. Now, what if it is, and an example of that would be something like CuSO4. Copper is a metal. Therefore, we know that that substance is a salt. We look up copper. Here, let's just do this. We look up copper on the periodic table, and copper is element 29, so it's a metal. Because it's a metal, we know that it is a salt. Then we check this on the periodic table. Copper can have more than one charge. So we split this in half, and we look up the charge of sulfate, and it's -2. So this is -2, so this is +2. So this salt then, +2 divided by 1, this salt would be copper 2 sulfate. All the things that you learned and practiced last time in class. Now, what if the first element, the first thing, is a nonmetal? Well, if the first thing is a nonmetal, then we know that we've got a molecule. At this point, we use the prefixes to indicate how many of each we have. If we only have one of the first atom, we do not use mono, and the second one ends in IDE. So for example, if we've got CO2, we've got one carbon, but we don't call that monocarbon. And then we've got 2 oxygens, so we call that dioxide, and that would be carbon dioxide. Notice the difference. First element is a nonmetal, it's a molecule. First element is a metal, it's a salt. Now, what about if we want to go the other way and we want to write the formulas? If we have a salt, again, remember, if it's a salt, the first element is a metal. If we have a salt, remember how to write the formulas. The first thing that you're going to do is write down the abbreviation and the charges of the ions. Remember, the polyatomics end in "ate" or "ite." Then you find the least common multiple. Then use subscripts to figure out how many of each you've got. And then remember to use parentheses if you need more than one of a polyatomic. All of the things that you learned last time. So for example, if we have iron 2 nitrite or nitrate, and if we want to write its formula, iron 2 is Fe plus 2. Remember, iron is Fe. That's a metal. This is a salt. So we would look at iron and we would go, wait, iron is a metal. That's a salt. Then we've got nitrate. Nitrate is NO3, and it's minus 1. Then we find the least common multiple of plus 2 and minus 1, and that's plus or minus 2. That means we need 1 iron, and we need 2 nitrates. That's NO3 in parentheses 2, because we need 2 of them, and that would be iron 2 nitrate. So what if we look at the first element, and the first element, as in the example of something like dicarbon tetroxide, we look at this, and carbon is the first element, and that thing is a nonmetal. Well, then we know that we've got a molecule that we need to name. And again, the prefixes just tell us how many. So dicarbon would be C2, tetroxide would be O4, and that would be dicarbon tetroxide. So guys, this is the challenge that lies ahead of you then. Looking at homework assignment number 3. Grab that with me now. Looking at homework assignment number 3, you'll notice that the first page, these are all molecules. The first 10, formulas write the names. The next 10, names write the formulas. But then when you turn it over again, you'll notice what it says. Mixed ionic and covalent naming. In that next 10, some of these are salts, some of these are molecules. You've got to figure out which is which so that you then know how to name them. Similarly, down below, you've got a mixture of salts and molecules there. And again, you need to figure out which are the salts and which are the molecules so you know how to handle them properly. Turning the page again, this is also a mixture of salts and molecules. And finally, the bottom is also a mixture of salts and molecules. So guys, you'll see that the first page is just molecules. The following 2 pages are a blending of both. You'll see the answers are already tagged up on the wall. Feel free to check as you go. And the remainder of the day today is yours to work through this homework and get these figured out.